How a three-phase rectifier works. A three-phase rectifier is a type of rectifier that is used to convert three-phase AC power into DC power. It typically consists of 6 diodes arranged in a bridge configuration. 1. Input AC power. The input to the three-phase rectifier is three-phase AC power, which typically consists of 3 sinusoidal waveforms that are 120 degrees out of phase with each other. 2. Rectification. The 6 diodes in the rectifier are arranged in a bridge configuration, with each pair of diodes connected to one of the 3 input phases. The diodes conduct current in only one direction, so they allow current to flow from the input phases to the output DC bus in a controlled manner. 3. Output DC voltage. The output of the rectifier is a pulsating DC voltage that is at a higher voltage than the input AC voltage. The output voltage is the sum of the 3 input voltages, minus the voltage drops across the diodes. 4. Filtering. The output of the rectifier contains a significant amount of AC ripple, which can be reduced using capacitors or inductors to filter the output and produce a smoother DC voltage. The output voltage of a three-phase rectifier is a pulsating DC voltage with a frequency 3 times the input frequency. The peak-to-peak voltage ripple in the output voltage is proportional to the load current and the capacitance or inductance of the filtering components. Three-phase rectifiers are commonly used in industrial applications where high-power DC voltage is required, such as motor drives, battery chargers, and welding power supplies. They are more efficient and produce less ripple than single-phase rectifiers, making them well-suited for high-power applications. Advantages of using a three-phase rectifier over a single-phase rectifier? 1. Higher power output. A three-phase rectifier has a higher power output than a single-phase rectifier for the same input voltage and current. This is because the three-phase input provides a more constant source of power, which allows for a higher output power without exceeding the voltage and current ratings of the rectifier. 2. Smoother DC output. A three-phase rectifier produces a smoother DC output voltage with less ripple than a single-phase rectifier. This is because the three-phase input provides a more constant source of power, which results in a smoother output waveform. 3. Higher efficiency. A three-phase rectifier is more efficient than a single-phase rectifier for the same output power. This is because the three-phase input provides a more constant source of power, which results in less power loss in the rectifier. 4. Better reliability. A three-phase rectifier is more reliable than a single-phase rectifier because it has fewer components and operates at a lower current density. This results in less stress on the components and a longer operating life. 5. Lower cost. A three-phase rectifier can be less expensive than a single-phase rectifier for the same output power. This is because it requires fewer components and operates at a lower current density, which can result in lower component and manufacturing costs.